In this video, we will learn supremum, infimum, maximum and minimum. If we consider a set E, so E is a set where x element of R and x is less than 1. So if we draw number line, if we draw this set on the number line, then it is like this. So what is the upper bound here? So here upper bound, this 1 is upper bound, then 2 is upper bound, 3 is upper bound, 4 is upper bound, 4.1 is upper bound, 5 is upper bound. That means you have infinitely many upper bounds. Okay, so among all of this upper bound, which one is the lowest one? We need to find which one is the lowest one. So if you consider 0.99, then it is not the upper bound. Why? Because there is a number which is more than this one. If you consider 0.99, this is more than that one and it is less than 1. Okay, so this one is not upper bound, this is not also upper bound. Okay, so among all of those upper bound, which one is the lowest one? So here 1 is the lowest one and it has a special name that is called supremum. Okay, so if we define supremum, or you can say least upper bound, the another name of supremum is least upper bound. Okay, least upper bound. Suppose S is a set, S is an ordered set and E subset of S and E is bounded above, because if it is not bounded above, then we will not have any upper bound. Okay, suppose there exists beta element of S with the following properties. There are two properties. So first one is the number beta should be upper bound. So beta is an upper bound of the set E. Like here we have upper bound 1, 2, 3, 4, 4.15, those are all upper bounds. So beta should be an upper bound. And second condition, for epsilon more than 0, beta minus epsilon is not an upper bound of the set E. Like here, if we consider epsilon equals to 0.01, then if you subtract 0.01 from 1, then you will get this number. So this is not the upper bound. Okay, so for epsilon more than 0, beta minus epsilon should not be upper bound of the set E. Then beta is called, then this beta is called the least upper bound, that means among all of this upper bound, this is the least one. Okay, so least upper bound or the supremum of E, of the set E. We write beta as supremum of the set E. For example, if we consider, the set E equals to x element of R such that x is less than 2, then supremum of this set E is 2. So this 2 is the supremum. If we draw the number line, then it would be like this. So this is 0, this is positive infinity, this is negative infinity, 1, 2, 3, negative 1, negative 2. So x less than 2. Okay. So this is our set. And these two, so these two is the supremum. So this is supremum of the set E. And all other numbers, all other numbers are upper bound of the set E. So those numbers are upper bounds of E. So among all upper bounds, 2 is the least one. Now how about infimum? Or it has another name, the greatest lower bound. Greatest lower bound. Now suppose S is an ordered set. S is an ordered set, and E subset of S, and E is bounded below. That means it should have lower bounds. Suppose there exists an element alpha element of the set S with the following properties. So what is the first property? First property is the number alpha should be lower bound. Alpha is a lower bound of E. And so if you think the number line, Okay, we'll discuss in example. And next property is for epsilon more than 0, alpha plus epsilon is not an upper bound, sorry, is not a lower bound, of the set E. So if these two conditions satisfy, then alpha is called the least lower bound or infimum. Okay, so if these two conditions satisfies, then alpha is called the greatest lower bound of E, of the set E, or the infimum of E. Okay, and we write this one as, we write alpha equals to infimum of the set E. Now to clarify this, let's discuss an example. So for example, let E is a set and it is for x less or equals to r such that x more than -2. Okay, then here what is infimum? Now if you draw the number line, so if you draw the number line, so this is 0, 1, 2, -1, -2, -3. So E is which part? More than -2. So it is more than -2. This part, okay. It is this part. Now it has lower bounds, -2. -2 is a lower bound because all of the numbers is more than -2. How about -3? -3 also lower bound. -3, -4 is also lower bound. That means any number less than -2, any number less than -2 are also lower bounds of the set. So those are lower bounds of E. Okay, so it has infinitely many lower bounds. So among all of those lower bounds, which one is the greatest? So -2 is the greatest one. Okay, -2 is the greatest one. But if you move little bit right here, that is not the greatest lower bound because this number is not the lower bound. Okay, there is a number which is less than this part. So for this set infimum, then infimum is infimum of the set E is -2. So alpha should be a lower bound of the set E. That means here 2 is the lower, -2 is the lower bound, and for any epsilon more than 0, alpha plus epsilon is not a lower bound of the set E. Like if you consider -2 and if you consider any number, suppose epsilon equals to 0.5, then -2 plus, if you consider epsilon equals to 0.5, then -2 plus 0.5, which is -1.5. So -1.5 is not the lower bound. Okay, so for any epsilon more than 0, alpha plus epsilon should not be lower bound of the set E. So if that two conditions satisfy, then that would be the infimum or greatest lower bound. Now we will discuss the maximum and minimum. So what is maximum? Or minimum. So for maximum, we can go this side. So here, what is supremum? Supremum is 2. Okay, supremum is 2. But is the 2 in the set? The exact 2 is in the set? This 2? The answer is no. Why? Because there is no equal sign here. There is no equal sign here. But if there is an equal sign here, that means this 2 is also in this set. This 2 is also in this set. Then it would be the maximum. So if there is an equal sign here, then its supremum would be 2, also maximum would be 2. But in this set, there is no equal sign, so it doesn't have any maximum. So what is the definition? Suppose S is an ordered set. S is an ordered set. E subset of S and supremum of the set E exists. Okay. So S is an ordered set and E subset of S and supremum exists. If that supremum, if supremum of the set belongs to S or belongs to E, sorry, belongs to the set E, then it is the maximum of E of the set E and is denoted by maximum of max of E. Okay. For example, if we consider E equals to X belongs to R such that X is less than or equals to 2, okay, so X is less than or equals to 2, then what is supremum for this number? Supremum is 2. So supremum of this set E is 2 and this 2 belongs to this set and 2 belongs to E. So maximum of the set E is 2. Okay. So maximum is 2. Now we'll give more example about the supremum, infimum, maximum, minimum. So how about the minimum now? So the definition of minimum is, so if we draw this number line, if we draw in number line, so 0, 1, 2, 3, -1, -2. So this set is less than or equals to 2. Okay, so less than or equals to this direction. So these two is our supremum as well as maximum. So supremum of E is equals to 2, and that is also maximum of the set E. And all of those numbers are upper bounds of the set E. Now minimum suppose S is an ordered set. Suppose S is an ordered set, E subset of S and infimum of the set E exist. So if the infimum of the set E belongs to the set E, then it is the minimum of E and is denoted by minimum of E. So we can write here small letter m, maximum. For example, if we consider a set E, so let E x belongs to R such that x is more than -2. So we are considering this set -2, -3, 1, 2. This is negative infinity, this is positive infinity. So our set is more than or equals to -2. So this part, it goes this direction. So any number more than -2 would be in this set. So what is the infimum of this set? So then infimum of the set is -2. Infimum of E is -2 and -2 belongs to the set E. So minimum of the set E also -2. So this -2 is infimum as well as minimum. But if there is no equal sign here, then there would be no minimum. Okay, since there is a equal sign here, so its minimum is -2. Now if we consider a set, suppose E is 1 over n such that n is natural number. So when n is 1, this one is 1. When n is 2, then it is 1 over 2. When n is 3, then it is 1 over 3, and it's keep going on. Now what is the this is decreasing, right? This is decreasing. So what is the supremum of this set? Supremum is 1, because 1 is the largest value of this set. So 1. And what is the maximum? Maximum of the set E. Is the supremum belongs to the set 1? Yes. Is 1 belongs to the set, so maximum also 1. Now what is the infimum of the set? So infimum of the set is, so it decreasing, and when n approaches infinity, then 1 over n is 0. Okay. So for this set, what is the lowest value? Lowest value is 0. So its infimum is 0. But is 0 in this set? No, 0 is not in this set. So there is no minimum. Since 0 is not element of E, no minimum. Okay, no minimum. Now we will give more example of supremum and infimum to clarify this. A few more examples of supremum, infimum, maximum and minimum. If you consider a finite set, suppose it is 1, 2, 3, it's a finite set. So what is the largest element? Largest element is 3, so its supremum is 3. Now for this set, the number 4 is also an upper bound. Okay. For this set, the number 4 is also upper bound, although it is not the least upper bound, okay, and hence not the supremum. And in this set, what is the lowest element? Lowest element is this 1, so infimum is 1. The number 0 is also lower bound for this set, but 0 is not the greatest lower bound, hence it is not the infimum. So infimum is 1. Now if you consider this set, so x varies from 0 to 1. So what is the largest value of the set? Largest value is 1, so its supremum is 1. Now if you give equal sign, then the supremum would be same, so its supremum is 1. If you consider only this part, so supremum is 1 and 1 is also in this set, so maximum is also 1. Okay, so for this set maximum is 1 because 1 belongs to this set. There is equal sign here. But if you consider this part, so here supremum is also 1, supremum 1, but 1 is not in this set. So 1 is not supremum, sorry, 1 is not maximum of this set. Okay, since 1 is not in this set, so 1 is not maximum of this set. Similarly for infimum, if you consider this set, so 0 is the lowest element, and if you give equal sign here, then it would be same, so infimum is 0. But if you consider only this set, so what is the minimum? So infimum is 0 and 0 also in this set, so 0 is minimum of this set. 0 is minimum of this set. And if you consider this set, so 0 is infimum for this set, 0 is infimum, but 0 is not in this set, so 0 is not minimum of this set. 0 is not minimum of this set. Now for this set, x belongs to rational number and x square less than 2. So if you take square root both sides, then it is square root of 2, and all of these numbers is less than square root of 2, so its supremum is square root of 2, but it doesn't have any maximum because square root of 2 is not belongs to this set. Similarly, if x cube more than 2, then if you take cube root, then it is 2 to the power 1 over 3, and all of this number x is more than 2 to the power 1 over 3. So infimum is 2 to the power 1 over 3, and this number is not in this set. So this is not the minimum. This is not the minimum because it doesn't belong to this set. But if there is equal sign here, then it would be the minimum. If you consider a sequence, so supremum of this sequence, so when n is 1, this is 1, 1 over 1 is 1. When n is 2, this is 1 over 2. When n is 3, then it is 1 over 3. So did you see this sequence is decreasing? This is 1, this is 0.5, this is 0.33. So it is decreasing. So what is the largest element of this set? Largest element is 1. So its supremum is 1. And this supremum belongs to this set. This supremum belongs to this set. So its maximum also 1. So this one also maximum. Now if you consider this set, so it is decreasing. Now when n approaches infinity, then it will approach 0. Okay. So what is the lowest value of this set? Lowest value is 0, and this is the infimum. 0 is the infimum, but 0 is not in this set. Since 0 is not in this set, so 0 is not the minimum. 0 is not the minimum of this set. Similarly, this set, it is increasing. This is increasing. So if we take when n approaches infinity, this is the general form of this sequence. So when n approaches infinity, this belongs to, like, this approaches 1. So supremum is 1, but 1 is not in this set. 1 is not in this set, so 1 is not the maximum. Although 1 is supremum, but 1 is not the maximum. Similarly, here infimum of this set is 1 over 2, and because this is the lowest one, this is the lowest, and 1 over 2 belongs to this set, so this is the minimum. So this is both infimum as well as minimum. Thanks for watching.